Hello everyone, this is going to be the first of two lessons that I'll put together for you on organic compounds. I'll split it up so it's not too long for one single presentation. So in this one I'll introduce organic chemistry and I'll talk about the writing and the naming of formulas for hydrocarbons and for halogenated hydrocarbons. And then in the next one I'll talk about cyclical hydrocarbons, alcohols, carboxylic acids, and esters. So first of all, organic chemistry. When we talk about organic chemistry, what we are really talking about is the chemistry that does involve carbon compounds. So most carbon-containing compounds we consider to be organic. There are a few exceptions. So things like carbon dioxide, we generally don't call that one an organic compound, even though it does have carbon. And cyanide as well, we usually don't consider that one to be organic either. So many, I don't know if it's millions, but a lot of different organic compounds. So many of them are naturally occurring. Other ones are synthetically or human produced. And of course, more and more can be produced all the time. So this is why we could say, well, at least potentially millions of different organic compounds would then be possible. So each organic compound is able to form 4 bonds. And so that line that we saw there, I was just going to try and shift it over here. So this thick line, that is what we use to represent a bond. So every single carbon has to have 4 of these lines representing a bond attached to it. So we'll take a look at a few different examples on the next slide of what this looks like. But carbon is kind of special because it can form single bonds, double bonds, or even triple bonds between carbon atoms and sometimes between carbon and other elements from the periodic table as well. So these are 3 of the simplest of the organic compounds, and these ones you'll notice that there is only hydrogen and carbon, and for that reason all of these are referred to also as the hydrocarbons. And we'll take a look at some specific examples of hydrocarbons and where you would encounter them in everyday life. So this first one here really important because again, each one of these lines shows that there is a bond. This one here is the simplest organic compound that there is. This one has 1 single carbon, that is it. It can't get any simpler than this. And this one is actually methane, which is natural gas, which is what we typically use to heat our homes. So every single carbon, again, has to have 4 of these lines, 4 of these bonds attached to it. And in this case, each one of these, I'll just number them, 1, 2, 3, 4. Each one actually has hydrogen, which is attached to it. So whereas carbon always forms 4 bonds, hydrogen always forms 1 bond that we can see in the picture here. We'll come across some other examples later as well. Oxygen is always going to have 2 bonds that are attached to it. And that's as much as we'll need to know in terms of naming of our organic compounds. This one here is the first one that we have with a double bond. So here it is, the double bond between the 2 carbons that we are talking about. And this is the simplest of a category that we call the alkenes. You can't make it any simpler for an alkene because you need to have a double bond, which means there needs to be a minimum of 2 of the carbons. So again, if we do take a look at the bonds, this carbon here, we have 1, 2, 3, 4 lines attached to it. And if we take a look at the second carbon here, we again have 1. We get to count these ones again, 2, 3, 4 bonds attached to that carbon as well. The last one here, this is what we call an alkyne. So the names that I'm using, we'll come across this, but here the ending is A-N-E when we only have single bonds between the carbons, like the example that I gave you here. This one here where we have a double bond, we change the ending to E-N-E. So this one is actually what is referred to as ethene, and we'll see where that comes from. But E-N-E if there's a double bond. And if there's a triple bond between the 2 carbons, now we have the ending the I-N-E. And this one here, in fact, is ethine for this particular organic compound. But we'll get into naming and writing the formulas of a whole bunch of these. Starting with the simplest, and these are the alkenes. So these are the ones that, again, have no double bonds, no triple bonds between carbon atoms. So I'll show you a picture on the next slide as well to make it a little bit more visual. But if we do have alkanes that have less than 5 carbons, they are vapors, they're gases at room temperature, just like the methane that I just showed you. That is a gas at room temperature. Longer ones, they can be liquid, and longer ones still, like paraffin wax, that is a solid. These can be made up of either straight or branching chains. So just to give you a quick example here, I'm just going to draw the carbons. I'm not going to draw the hydrogens. So we can have a straight chain like this, but what we can also have is exactly that same straight chain, but now I can put a branch in here, and maybe I can put a branch in over here as well. Okay, carbon branches that we can also have. So when we do take a look at the straight chain, the longest straight chain is what we're interested in, and the longest straight chain is what we call the backbone. And as we'll see, that's the very first thing that we're going to kind of look for when we're going to be naming an organic compound. This one here, you have a picture that's similar to this in your data booklet. On page 9 of your data booklet, I believe, is where you can find that information. So this is actually quite useful. So going from the top down, what we can see is that we start off with just one single carbon atom, and then we have 10. There are different ways that we can represent this. So if I take a look at, well, I'll take a look at a fairly simple one here, this one here. This is one way to write it. And what it's saying is that this carbon right here has to have 3 hydrogens attached to it. And that's also attached to this next carbon. So we actually saw this one. So this one here is the ethene. If we take a look at the next one, just another way to write it, we could write it like this, very, very simple. And here we're making assumptions. The assumption that we're making is that every single one of these carbons would have other bonds, and there would just be a hydrogen on it. Sometimes we show it just with a line. And again, the assumption is that, well, now we're indicating the number of bonds, but we're assuming that there's a hydrogen on it. To make it the most clear, we would just write this, an H on each one of these, where I do have the bonds. We're filling it up with the hydrogen, so this is our hydrocarbon. And again, every one of these carbons, if you count them up, will now have 3 hydrogens for the ones at the end, 2 the one in the middle, but 4 bonds for each one of the carbons. So another way to write this, well, is just exactly the way that they did show it here. But you need to make sure that you have the number of hydrogens correct, corresponding to the number of bonds that we have for the carbon. Names that they have here, these are prefixes for organic compounds. Again, we can take a look at this in your data booklet a little bit later, but meth is referring to organic compounds that have 1 carbon. F is 2 carbons. Prop is 3 carbons. So you might recall from naming molecular compounds that we use some different prefixes. Mono for 1, di for 2, tri for 3. So these are specific for organic compounds, and they are specifically referring to the number of carbons that we do have. So what we do see here is that all of these have a very low boiling point. So all of these are going to be gas or vapor at room temperature. So everything up to 4 different carbons in this hydrocarbon chain, which is butane, will be a gas. And then, well, depending upon what the temperature is outside, pentane could be a liquid or it could be a gas, but the boiling point is 36 degrees Celsius. The pattern, though, is the longer it gets, the higher the boiling point is going to be. And again, if we make this even longer, so if we do have paraffin wax, which is C25H52, this one here is now going to have such a high boiling point that it is going to be a solid at room temperature. So how do we name these alkanes? So this is kind of wordy what I have here. The first thing that you need to do is you need to identify your parent chain, the longest number of carbons that you have. So you might have something that has a whole bunch of carbons, something like this, and maybe we have a branch in here. So the very first thing that you need to do is you need to determine what is the longest chain that you do have. So what I like you to do, and what I strongly recommend that you do, is, let me just get back to that. need to just go back to where I was here. Jumped ahead somehow. I was trying to get a different color of pen here, but maybe it's not going to let me do that at this point. Oh, here we go. Okay, so the longest parent chain. So if we go across here, then we have 4. If we go down, I would only get 5 for the longest parent chain. If I go up this way, then I would get 1, 2, 3, 4, 5, 6, 7. So that would be our longest parent chain that we do now have in this case. Okay, so yeah, like I've done here, what I recommend you do is this: draw a line through your longest parent chain just to confirm that that is the longest possible chain that you can come up with. Number the carbon atoms starting at the end that is closest to the branch. So here we do have a branch. Okay, it's right here. So we want to start counting at the end that's closest to the branch. So in this case here, I made it right in the middle. So it wouldn't matter if we started this one here with carbon number 1, 2, 3, 4, or if we start at the other end, it would still be 1, 2, 3, 4. So we could start counting at other end, but we do need to make a decision. If, for example, I had this branch here, now this branch is closest to this end. So this would be my carbon 1, 2, 3, 4, and now this would be 5, 6, and 7. All right, so you do need to get their numbering straight as well. So we're going to use the appropriate organic compound prefix. So those are the ones we just briefly took a look at with that previous table. Again, all of this is in your data booklet, so you don't need to remember these prefixes. And this is for the number of carbon atoms in the parent chain. So because for this one here, I have 7, this is a hept, and hept is the prefix, and ANE, so this would be a heptane. But we also have a branch that we need to deal with as well. So if a branch does exist, and that's what I just circled, is the branch here, identify the carbon number that it's located on. So it's located on carbon number 3. Again, we're starting to count from the carbon that's closest to that branch. The carbon in the parent chain that's closest to that branch, that's our carbon number 1. So we're going to use this number to indicate where the branch is. Whenever you have branches, we change the ending to YL. So this is a 1-carbon branch, which is a meth branch, but we're going to change the ending to YL because it is a branch. And now I just need to specify where this is. So the branch name is written prior to the parent name, and they are arranged alphabetically. And prefixes are included if we do use the prefixes. So this one, specify where it is using a number. It's on carbon number 3. So this would be a 3-methyl heptane is what we would call this one. Let's take a look at a few other examples though, with some other branching and multiple different possibilities. So let's take a look at this one here. So I'll try and draw these different ways as well. Here I'm going to put in all of the bonds. So I won't add the hydrogen in, but I will make sure that each one of my carbons does in fact have 4 bonds. And again, we're making the assumption that on each one of these, it is going to be a carbon. So now what we want to do is we want to make sure that we find the longest possible parent chain that we do have here. So in this case, there are multiple different ways that I can draw it. I can go 1, 2, 3, 4. I can start here and go 1, 2, 3, 4. So many different ways, but the longest that we can get anyway is going to be 4. So I'm just going to draw it going straight across. That's our parent chain. Okay, so what do I have? I have 4. I have no double bonds, so it's going to be a bute. Bute is the prefix for 4. There is no double or triple bonds, so the ending is ANE. This is butane. Now remember I said circle the branches that you have. So we have a branch here that's sticking out. We have a branch here. We have 2 of them. So because we have 2, now we actually use those molecular prefixes, and it's a di because both of them are methyl. So we have a methyl here, We have a methyl here. Again, because it's a branch, we're calling it methyl. Because there are two, we have a dimethyl. So in front, I'm going to write the dimethyl. But we even need to do something else. We need to specify where, on which carbons within the parent chain, we find these branches. So this one's fairly symmetrical. It doesn't matter which end we start at. So I'll start here. This is my carbon number 1, 2, 3, 4. So where do I find the branches? I find a branch on carbon number 1. So I'm going to go 2, or sorry, on carbon number 2. And I find another one on carbon number 3. So I'm going to go 2-3, or 2, 3 dash dimethylbutane. So that is the total name of this compound that we have here. Let's do one more and then talk about going in the reverse direction. Okay, let's do this one here. So this is just kind of the skeletal form. I'm not even showing the bonds. So the first thing, once again, is to find your longest possible carbon chain. And again, it doesn't necessarily have to be going straight across. So in this case here, we can actually go like this. And that would give us our longest possible parent chain. I'm actually going to change something up here a little bit, just to get us a little bit of variety. Go back to the previous color that I had. And what I'm going to do is I'm just going to change this one here to a C. So now I do want to find the end that's closest to the branch. So I have two different branches. So let me circle those branches. I have a branch here with 1 carbon. So this is a methyl branch. And I have another branch here with 2 carbons. So this one is an ethyl. It's an ethyl branch. Ethyl is 2 carbons. So which end am I closest to? Again, this is pretty symmetrical, but we go alphabetically. So E comes before M. So I'm going to start counting this end. This is my carbon number 1, 2, 3, 4, 5, 6. So 6 is a hex, and this is a hexane. But now we need to add the branches in. So always start with the parent name. It is a hexane that we have. I'll just write it down below here again. It's a hexane that we have. Now let's take a look at the branches. Alphabetically, E comes before M, so we're going to name the ethyl first. Where is it? It's on carbon number 3. So this one would be a 3-ethyl. No spaces between any of these, by the way. No spaces between numbers, the dash, the letters, or between the words. So this is a 3-ethyl. And now we have a 4-methyl. So we can go dash 4-ethyl. And again, I have to shift this over so there's no space in here. This is a 3-ethyl, that's a methyl, 4-methyl hexane that we do have here. I'm just going to do one more thing. I'm going to add another carbon in here. That would be another branch. So now I would have to change this, and this would now be a dimethyl. And they're both on carbon number 4. So you do need to write that number 4 down twice. So this would be a 4, 4 dimethyl hexane. Okay, so 3-ethyl, 4,4-dimethyl. Hexane would now be the name of this compound that we have here. So all of this is going from the formula to the name, but you also have to be able to go in the opposite direction. So let's say that we have this one here. Let's say that we have a 3-butyl methyl, 2,2-dimethyl decane. So this is really kind of messy, and I just want to tie in a whole bunch of ones with you here. So start with the parent. Okay, we have 10. Deca is 10, so we have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Just draw them in a straight chain. So now let's take a look at our branches. Again, it's alphabetical. B comes before E, comes before the M. But where I have the lowest numbers are actually the methyl. So I'm going to start counting at this end. It's arbitrary in this case. I'm going to say this is carbon number 1. So what I'm told is that on carbon number 2, I have methyl groups, and I have 2 of them. On carbon number 3, I have, and this actually isn't going to work out for me the way that I did this. I need to change something up a little bit here, and I'm not sure what I can change up because I didn't think of this ahead of time, and it's actually not going to quite work this way. If it were to work this way, then what I would put on here is the butyl. And the reason why that would no longer work is because that would no longer be my longest parent chain going in this direction. And so what I'm going to do is I'm going to change this, and I'm going to make this a tri-methyl, and I'm going to go 2,2,3 trimethyl. And then I'm just going to put another methyl group on here. And now my 1, 2, 3, 4, this is where I have the ethyl group. Okay, so this one would now be my 4-ethyl. Here it is right here on carbon number 4. 2, 2, 3. This is one of them on 2, the other one on 2, the third one on 3, trimethyl. 10 carbons is the decene. So where do you come across these alkanes? Well, any kind of fuel. So if we're talking about, again, the methane that we use for heating, that is an alkane. Octane that you put in your vehicle, that is also going to be an alkane. Also lubricants, so fuels, lubricants, asphalt, all of these are simply going to be these alkanes. So bumping it up a little bit, now we're just going to stick double and triple bonds in here. So an alkene is where we have a double bond, and this got shifted over a little bit for me, but you'll see something that looks like this. And alkynes, they have a triple bond, so something that looks like this. And here we're talking specifically between the carbon atoms, in the hydrocarbon chain. So once again, there's still hydrocarbons that we are dealing with here. So how do we go ahead and name these? Well, it's actually no different, except we're going to have to change the ending. We need to specify where that double or triple bond is. And then we use the rules as well in terms of the branches, if there are branches. Okay, so name as the alkanes. Parent chain has to have that multiple bond in the parent chain. Change the ending to ENE if there's a double bond, or YNE if there's a triple bond. Specify the location of that double or triple bond by counting from the end that's closest to that double or triple bond. So let's take a look at some examples here. So we'll start with the formulas first. So here I have 4 carbons. So the prefix for 4 is going to be the but, but there's a double bond right here. So that means now it's not a butane, but it is a butene. But what we're going to do is we're going to sandwich in here the carbon number that double bond is going to begin on. So with my longest chain here, again, I can draw a line through it. You always need to start counting at the end that's closest to that double bond. So this is the carbon number 1, carbon number 2, carbon number 3, and carbon number 4. So I need to specify that the carbon begins on, or the double bond begins on carbon number 1, and where I put that is in between. Okay, so it is a 1. So this in fact would be a but-1-ene. How about some branches? What about if we have some branches in here? Let's take 5 carbon 1, Let's stick a branch up here, and let's stick a branch down here as well. Okay, so for these ones, what takes priority over the branch is now the double bond. So even though we have a branch here that's closest to the end on the right-hand side, the double bond takes priority over that. So this is our longest chain that we have here. But I need to start counting at the end that's closest to the double bond. So this is our carbon number 1 on the left-hand side, carbon number 2, 3, 4, and 5. Okay, longest parent chain, which means I have a branch here. It is a 1 carbon or methyl branch. And here is our 2 carbon or ethyl branch that we now have. So it is going to be a pent dash. It's on carbon number 2 that the double bond begins. So it's a pent 2-ene. And then it's just naming the branches. Alphabetically, E comes before the M. So this is going to be a 1, 2, 3 ethyl. I try and squeeze this in. A 3 ethyl and then a 4 methyl. Okay, so this is a 3 ethyl, 4 methyl, pent 2-ine. Let's do the reverse, starting with the name and writing the formula. Let's try this one here. Let's try a 4 ethyl, 2, 3 dimethyl, oct 3-ene. So what do we know? Start at the right-hand side. So normally you read from right to left, we're going to start at the other end. So it's an ene, which means there's a double bond. I have a double bond in here somewhere. The parent chain, oct, is 8. So I'm going to draw 8 carbons. 1, 2, 3, 4, 5, 6, 7, and 8. I'm going to put a double bond where? Starting on carbon number 3. Whatever end I want to start at, it doesn't matter. I'm going to start here. This is my carbon 1, 2, and 3. So beginning on carbon number 3, this is where the double bond is. Okay, so now this is our carbon 4, 5, 6, 7, and 8. So what else do I have? I have branches. So ethyl, on carbon number 4, I have an ethyl. 1, 2, 3, 4. This one here, I'm going to have an ethyl branch. On carbon 2, I'm going to have a methyl branch. On carbon 3, I'm going to have an ethyl branch. Okay, branches that we have, 8 for the parent chain, double bond, making it an alkene, and that is our compound. So common alkenes and alkynes, petrochemical industry, so plastics, for example, like it's showing in this picture here, welding, acetylene torch for welding that it's showing in this picture here. I did the alkenes. Let me just do 2 alkynes, like we're seeing with this picture here. So an alkyne, this is where we're going to have a triple bond. So we might have something like this. So we do have a branch, and the branch is closest to the right-hand side, but it doesn't matter. We go by the end that's closest to the double or triple bond, which means this one here is going to be our carbon 1. This is 2, this is 3, this is 4. We could either go up or down here. I'm going to call this one the branch, carbon number 5. So longest parent chain is 5. So it is a pent, but we have a double bond starting on carbon number 1, or sorry, triple bond. So it is a pent 1-ine. Now I have a branch on carbon number 4, and it's a methyl branch. So this is a 4-methyl pentyne. One more. Let's just write the name first. And let's call this one a one, two, 3 trimethyl. Hex 3-ine. And that's not going to work. I'm going to have to change this to a 1,2,2 trimethyl. Okay, so ine, we have a triple bond. Hex means we have 6 carbons that we're taking a look at. So drawing it, 1, 2, 3, 4, 5, and 6. I'm just going to start at the left-hand side, make this my carbon 1. Carbon 1, 2, 3 on this one. This is where I'm going to have the triple bond. So the reason why I needed to change this, by the way, is that these carbons here, they're already filled up, so I can't actually put a branch on either of those carbons. So where I do have branches then, I have a branch here on my first one. I have a branch here and another one on that one. Okay, so 1, 2, 3, that's my tride or all methyl. They're on carbons 1, 2 of them on carbon number 2, and my branch or my triple bond is on carbon number 3. We'll do one more here, and this is the organic halides. So these are organic compounds, again, carbon-containing compounds, only now they have a halogen that's also attached to them. So periodic table, the halogens, far right-hand side, right beside the noble gases, so they are group 17 on the periodic table. We can have these that are also attached to organic compounds, and these are typically synthetically human-produced compounds that we add these halogens in order to give the organic compounds different properties. So here we're going to name these as a branch, only the branches don't have their YL ending. We simply call the fluorine, which is attached to the organic compound, a fluoro, the chlorine, the chloro, bromo for bromine, and iodo for the iodine. So the general formula that we do have is, so X here is going to be our halogen. Again, this line should be up here showing the bond, and the R is just a hydrocarbon chain that we do have. So the rules are going to be exactly the same. We're just going to name it exactly like we've been doing for an alkane, an alkene, or an alkyne. If there are other branches, we would name them just as the ethyl branches or the methyl branches with the YL ending. Now we're going to use, again, the molecular prefixes for the number, and we need to indicate the position of the halogen. Start counting to the end that's closest to, once again, the branch that we do have, unless there is a double or triple bond, and then we need to start counting from that end. So let's take a look at a couple here to finish it off for this lesson. So let's say that we have, and let's just start with kind of a simple one here. And I will draw in the hydrogens for this one as well. So this is our carbon where we have hydrogen for 2 of the bonds and then a chlorine. And on the second carbon, we're going to have to fill it in with some hydrogens as well. So each of those carbons have 4. So if we take a look at our longest parent chain that we have for starters, we only have 2. There is no double or triple bond. So this is going to be an F, and it's going to be an ethane that we are talking about. But now we have a couple of these halogenated compounds. So we're going to name them as branches, only it's not the YL. So this one is a bromo. This one here is a chloro. We're going to go alphabetical again. So bromo is coming before, B coming before the C. And that's the one that we're going to call our carbon number 1. This one, carbon number 2. So this would then be a 1 bromo, 2 chloroethane. Let's stick in a double bond for the next one here. So let's go with this here. I won't draw the hydrogens in for this one. So our longest parent chain that I have here, I just drew it going straight across, which means we have 4 for our longest parent chain. We have a double bond, which means it's going to be an ene. So 4 is a bute. Double bond, we need to specify where it is. We count at that end where we have the double bond. So this is our carbon number 1, which means it is on carbon number 1, the double bond. So it is a bute 1 ene. And then I'm going to circle the branches that we have. So this one here is a chloro branch, like we saw up above. These ones here are iodo branches. And we have 2 of them. So we're going to end up with a diiodo, just like we did when we were naming the ethyl and the methyl branches. And we need to specify what carbon they're on. We go alphabetically, so this one we're going to name first. So this is going to be our 1,2-chloro. The iodo, they're both on carbon number 3, so we need to write that down twice. 3, 3. Put in the di to indicate again that there are 2. Iodo bute 1 ene is the name that we have for this one. Just one more going in the opposite direction. So this time I'll give you the name and we'll write the formula. So we'll go with 2-bromo methyl. And we'll make it a 3. Oh, actually, I'll maybe just stop there with that. 2-bromo, 3-methyl. And let's make it a pentane. Okay, so 5 of them. 1, 2, 3, 4, 5 is our pent. No double or triple bonds. On carbon number 2, whichever end we want to start with, we're going to have a Br, and we're also going to have our CH3. That's on there. Some examples of these ones: halogenated organic compounds from the petrochemical industry. Quite often we do add these halogenated compounds to hydrocarbons, and that turns them into different kinds of petrochemicals. Also for herbicides and pesticides. And something that we're going to talk about at the start of the next lesson are going to be some cyclical organic compounds. But we'll stop with that for this lesson here. It's gone on long enough. And we'll pick up at this point with the next lesson.